Hello everyone, welcome to National Defense Institute's PYQ series. Here we have CDS 2 2021 question paper. So we are going to discuss about the questions, their solutions and their explanation for physics questions from this particular question paper. So let us move on. Where should an object be placed in front of a convex lens to get a real and enlarged image of the object? So here we are going to get real and enlarged image of the object, and they are asking you where your of the object image should be obtained as real and enlarged. Where should the object be placed? For this we have to go to the object image tabular column. I hope all of you are thorough with this. This table is very important, okay, and it is the same for convex lens and concave mirror. I'll teach you a simple trick to remember this. If you place the object at infinity, you will get the image at focus, okay, and if you place the object beyond 2f, you will get the object between f and 2f, okay, on the other side. Let us call it as f dash to f dash, and if you place it at 2f, you will get it at 2f dash, and if you place it between f dash and 2f dash, you will get it beyond 2f dash, right, and if you place it at focus, you will get it at infinity. Now as I told you, this table is very important, and this table is same for both convex lens and concave mirror. In concave mirror, only one small correction, we call the 2f point as center of curvature. That's all. We don't have any other changes over here. In mirrors, you will get the object and the image on the same side. It is a reflecting thing, so you will get, if you place an object here, it will undergo reflection, you will get the image over here, right. In a lens, if you place an object over here, refraction happens, so image will be formed on the other side. That is why you are having dash, 2f dash, f dash, all those things on this side, and you call this as f and 2f. On the mirror, you don't have the concept of behind the mirror, so we are not having that concept, simply we are calling it as center of curvature. Now the simple trick to remember this is, the beginning part, these two things are smaller sizes. It starts from small, it goes big, it increases, it is increasing order, okay. So as you move down the table, the object size increases. This is the smallest one, and this is the biggest one, okay. This is the smallest one and this is the biggest one. As you move down the table, this keeps on increasing, where you have a same size over here. It reaches the same size, then it keeps on increasing, okay. Object size is equal to image size is under this condition. So over here you should get an enlarged image, that is, it should be magnified. It is not going to be the same size, or it is not going to be of a very small size. You should get it enlarged. So where should an object be placed in front of the lens to get a real enlarged image, right? So look at the options over here. If you place it at twice at the focal length, twice at the focal length is this criteria. I will put here as option A. So you are getting it as same size, right? So this cannot be your answer. Then you are placing it at B. This is option B. If you place the object at infinity, you are going to get a very small object. So this is also not an option. Then between principal focus and twice the focal length, this one, between principal focus and twice the focal length, of course you are going to get an enlarged image, but what is going to, let us keep this option on hold. This case is correct. Let us keep this on hold. Beyond twice the focal length. Beyond twice the focal length is option D over here. As I told you, as you move down the table, the size increases. This is the smallest, this being the smallest and this being the biggest. But over here, it is not going to be of the increased order, right? Hence, this is also not the case. Hence, we end up with the option C over here. Hence, the correct option is answer C. Moving on, next question. The magnetic field lines inside a current carrying solenoid are in the form of dash. So, here what we need to understand is inside a magnetic solenoid, the magnetic field lines will always be straight in nature. So, when you pass electricity through this, magnetic field lines are induced surrounding the solenoid in this manner, whereas inside the solenoid always the magnetic field lines will be parallel to each other. It will be straight lines in this form, it will be parallel to each other. Only when it comes out, it starts to move in this direction, forming the circular path of your magnetic field. But once it is inside, it is always parallel straight lines. An electric circuit is consisting of a cell, an ammeter and a nichrome wire of length L. If the length of the wire is reduced to half, then the ammeter reading is. So, let us draw the circuit as it is clearly given. We are having a cell, we are having an ammeter and we are having a nichrome wire. In order to differentiate between the normal connecting wire and the nichrome wire, I have represented it in the form of a resistor. Okay. So, now this is the circuit where my current flow is existing. Now, when the length of the wire is reduced, what happens to the ammeter reading? First of all, what you need to understand is ammeter gives you what reading? It gives you the reading of current. So, they are asking you what will happen to the current value in the circuit once the length of the resistor is reduced. Okay. So, let us go to the relationship of resistor. R is equal to rho L by A. In this, what is happening to L? L is becoming L by 2. So, R will become rho L by 2 by A. That is equal to 1 by 2 my new resistance. Okay, I call it as Rn, rho L by A. So, this becomes 1 by 2 R. My new value of resistance becomes 1 by 2 the old value of resistance. So, resistance is getting decreased, resistance is reduced. Now, take to your Ohm's law, V proportional to I. From this we write V is equal to I into R and R is equal to V by I. So, now if R is becoming 1 by 2, what will happen to I? R and I are inversely proportional, as you can observe from this particular equation. So, when you increase the value of R, I will reduce. The vice versa happens over here. What is happening over here? R is getting reduced. So, what will happen to I? I will increase, right? By how much it will increase? That is given by this factor. If you reduce R by half, then your current will be increased by double the value. So, your current gets doubled. Understood? We are talking about two relationships over here. One is R is equal to rho L by A and the second one is R is equal to V by I. So, comparing these two things, we are going to tell that when you reduce the length, the resistance reduces. When the resistance reduces, the current increases. Next question. A ray of light traveling from a rarer medium to a denser medium. So, ray of light is traveling from rarer medium to denser medium. Let us understand what do you mean by this rarer medium, what do you mean by this denser medium, right? Rarer medium denotes, or rarer medium means the medium with less density, less number of particles, right? Denser medium represents more density. It has more particles in it. It is tightly packed. So, when light enters into a rarer medium, right, for example, if there are very few particles, very less particles, then the speed of the light will be more speed. It will travel with more speed. Whereas when it is entering a denser medium, the speed of the light will be less, right? You can compare rarer medium and denser medium to a crowded street. If the street is very crowded, it is very difficult to travel with your vehicle, right? You have to keep on honking. You cannot move at a steady space. Lot of obstacles, lot of people, so the crowd is tightly packed. The street is tightly packed, so it is denser, right? At the same time, when there is no crowd, the road is very free. You are able to walk very freely, or you are able to drive very freely. So that kind of street or that kind of medium, you can compare it with that of your rarer medium and denser medium. So how do you travel? When the medium is rarer, when there is no crowd, you travel faster. So the light also will travel faster in a rarer medium. The opposite of it happens in the denser medium. Now come back to the question. The light is traveling from rarer to denser. So what will happen? It is traveling with more speed in rarer. Obviously, when it comes to denser, its speed will be reduced. Okay, so the speed will reduce. Now coming to the bending up of light. The refraction itself means bending up of light. How does the light bend? When the light moves from rarer medium to denser medium, it always bends towards normal. This is like rules you have to remember. Towards normal. Okay, and when the light moves from denser to rarer, it always bends away from normal. Okay, away from normal. So please remember this. Rarer to denser is towards, denser to rarer is away. You can use any form of short acronyms to remember this. I teach my students one acronym, that is DRA. Denser, rarer, away. Okay, DRA. Please remember DRA. DRA is denser, rarer, it moves away. So when it moves from denser to rarer, it is moving away. The opposite will happen in rarer to denser. So it should move towards normal. So which are the two options that is fitting my explanation over here? It is my option B. Okay. So when the light moves from rarer to denser, its speed gets reduced and it is bending towards normal. I hope this concept is clear. Moving on to next question. What is the effect of pressure on human body on sand? So pressure, as we all know, is equal to force by area. Okay. So pressure is inversely proportional to area. What does this inverse proportionality represent? As you increase the pressure, the area will decrease, or as you decrease the area, the pressure will increase. Now if a person is standing, he is standing on the sand. What is the area in which the person is standing? The area is very less, right? Lesser the area implies more pressure. Okay. Whereas when the person is lying down, right? What happens? The area the person occupies is greater, right? The area the person occupies is greater, hence greater area, it means pressure is reduced. That is why you would have seen lot of short videos in science experiments and everything. You take one small pin, you poke it at the balloon will burst. The same thing, you take a wooden slab full of pins and you press the balloon on it, the balloon will not burst. Why? Because the area is more, lot of pins. One pin pointing at the balloon, very small area, hence the pressure exerted by that nail is very greater. That is why the balloon is bursting. But when many iron nails are there, the area gets increased, so the pressure is reduced and the balloon doesn't burst. Okay. So compare this with the options given to us. The correct answer will be, what will be the correct answer? Larger while standing than while lying, smaller while standing than while lying, same while standing and lying, larger while standing during the day and smaller during the night time when lying. Now we know it is not option C. Very good, very clear. please think about option A and D. Both are not similar. Okay. B is also wrong because it doesn't satisfy this, so we are not going to consider B. A and D is not similar. Please don't get confused, because A talks about general scenario, D talks about a specific time of the day. It doesn't mean that you cannot lie down during daytime, right? You for lying down and for standing, there is no daytime or night time. Daytime and night time is not going to affect your pressure. The area that you stand on, the area that you occupy, right, that is going to make a difference. Hence the correct answer is option A. Okay. Please be very specific and very clear. The time of the day doesn't depend upon the pressure. Pressure depends upon area. An athlete completes one round of circular track of diameter 100 meter in 20 seconds. What will be the displacement after 1 minute and 10 seconds respectively? Okay. So, we have to find the displacement for 1 minute and displacement for 10 seconds. Right. Now, let us go back to the definition of displacement. What does displacement mean? It is the shortest distance travelled by an object between the starting point and ending point. That is called displacement. Okay. So, for example, if you are having a track in this manner, a square track, a person is starting from point A, he is going around the square and he is reaching this point, he is going to point B, he is going to C, and he is reaching D. Then if the person is stopping at, this is the end point, let us consider the person is ending over here, he is starting over here, then the diagonal becomes the displacement. In the same manner, for a circular track, if the track is circular in nature, the diameter becomes the displacement. Okay. If it is moving end to end, right, if the person is moving from this point to this point to this point, then what happens? Then this chord, you have something called as chord in mathematics, that chord becomes your displacement. Okay. Like this, displacement is nothing but the shortest distance. We are calculating the shortest distance between 2 points, that is called as your displacement. Now, let us move on to find out what is your displacement going to be. So, right, now we are having a circular track. That track is having a diameter of 100 meters, right, and an athlete is completing one round in 20 seconds. So, let us assume the athlete is starting from the point A over here, he goes around the track. So, this is the path taken by the athlete, right, he comes around and he stops at A. This is called one round. Starting point, if itself he is returning, then that is called as your one round. So, when he completes one round, what happens to displacement? Displacement becomes 0. Agreed? Because starting point and ending point are the same. The person has come back to the same place, right? So, if you if you are not able to find a value for your starting point and ending point, then that becomes 0, right? So, let us calculate for 1 minute. What happens in 1 minute? In 1 minute there are 60 seconds, right? So, for every 20 seconds the athlete is completing one round. So, the athlete will complete 3 rounds in 1 minute, but the displacement still will be 0. Why? Because he is coming back to the starting point again and again, right? So, the displacement for 1 minute will be 0. Now, the displacement for 10 seconds. 10 seconds, how much the athlete will be able to travel? Let me take another color. The athlete is starting from A point, right? In 10 seconds, he will come to this point B over here. He will come half of the distance, right? 20 seconds if he is completing the full circle, then in 10 seconds he should come half of the circle. So now what is the distance? It is the distance between A and B. What is this distance between A and B? He is completing half a round. And what is this half a distance? That is equal to diameter, right? That is equal to diameter of the circle, and that diameter is nothing but 100 meters. So what is our correct option over here? 0 and 100 meters. Got it? A sound wave has a frequency of 4 kilohertz and wavelength 30 centimeter. How long will it take to travel 2.4 kilometers? So what are the things that are given to us? Frequency is given as 4 kilohertz. I am using n, the variable n, to represent frequency. Then wavelength lambda is given as 30 centimeter and the distance d is given as 2.4 kilometer. Now this I can write it as 4 into 10 to the power 3 hertz. This I can write it as 30 into 10 to the power minus 2 meters. This I can write it as 2.4 into 10 to the power 3 meters. I am converting everything into SI unit. SI unit of frequency is hertz. SI unit of wavelength is meters. SI unit of distance is also meters. Now coming to the formula. We know that velocity is equal to frequency into wavelength, right? Velocity is equal to frequency into wavelength. So frequency is 4 into 10 to the power 3 into 3 into 10 to the power 30 into 10 to the power minus 2. So what will happen over here? 4 3s are 12. So it is 120 into 10 to the power 1. So that is nothing but 1200 meter per second. Okay. This is my velocity. Now the age old formula of velocity. Velocity is equal to distance by time. We are supposed to find time, right? How long represents time? So time will be equal to distance by velocity. What is the distance? 2.4 into 10 to the power 3 divided by 1200. 2.4 into 10 to the power 3 is 2400 by 1200. 0 gets cancelled out. 12 1 times, 24 2 times. So the time is 2 seconds. So what is my option? Option A. Right? Got it? I am using two formulas over here. The first one is velocity is equal to frequency into wavelength. Second one is velocity is equal to distance by time taken. Okay? Speed or velocity, however you want to call it. Sound wave doesn't have direction, so speed and velocity means the same for that particular wave. Moving on. An electric bulb is connected to 110 volt generator. The current is 0.2 amperes. What is the power of the bulb? Direct formula substitution. What is the formula for power? Power is equal to V into I. What is V given? V is given as 110 and I is given as 0.2. You multiply, you get the answer as 22 watts. Direct formula substitution, direct solution. Okay. Need not spend more time on this. So like these kind of questions, try to save your time and utilize it for the previous questions where you need to have more time to calculate, right? That athlete circular track question and all, you need at least 2 minutes to find the answer. So try to save time over here and utilize that time in other questions. For example, this particular question, this is a direct theoretical question. So read the question, spend a few seconds on it, that's all, move on. Maximum 30 seconds. After 30 seconds, you need not be bothering at all, right? So let us read the question. Refraction of light as it enters from one transparent medium to another is due to. What is happening? Why is the refraction happening? Why is the light bending up? Is what the question is all about. We know when light moves from one medium to another medium, it is bending, and that phenomena of bending up of light is called refraction. But why is it happening? As I told you, the example earlier, crowded street and an empty street. right? If the street is very crowded, there are a lot of people standing, right? Here, everywhere there are people. What will you do? How will you travel in a car then? You will go straight like this, hit everyone and you will go straight? No, right? You will try to bend, try to find wherever the way is, and then you will go in this manner. Correct? But if the street is empty, what will you do? You will go straight when there is nothing in the street. When you don't have any people, the people are very less and they are also minding their own business and they are going. What will you do? You will go straight, right? So, why is the bending up of light happening? It is happening because of change in speed of the light. When the speed of the light varies due to the density of the material, then there is a refraction happening. Next question. A bus starting from a bus stand and moving with a uniform acceleration attains a speed of 20 km per hour in 10 minutes. What is its acceleration? So, acceleration, direct formula substitution, acceleration is equal to velocity by time. Here velocity is given as 20 km per hour and the time is given as 10 minutes. Students, one thing that you want to observe over here, please do not convert velocity from kilometer per hour to meter per second or kilometer per minute. No, bad idea, because the final answer is in kilometer per hour. If you look at all the options, the final option is in kilometer per hour square. So, what should you convert over here? You should convert the value of time, right? So, for 10 minutes you have to convert it into hours, right? 60 minutes is equal to 1 hour. So, 10 minutes will be equal to 10 by 60, that is equal to 1 by 6 hours, correct? So, substitute it in the formula, acceleration is equal to, you need not find the decimal value of it, that is not required, because anyway you are going to substitute in the formula, it is going to get cancelled out. So, you need not substitute, find the decimal value of it, keep it as fraction itself. Velocity is 20 divided by 1 by 6, denominator of the denominator goes to the numerator, right? This will go up, 20 into 6, 2 6 are 120, right? 2 6 are 12, 120 kilometer per hour square. So, the answer is 120 kilometer per hour square. Understood? I am not converting the velocity over here because my final answer is in kilometer per hour square. So, when I convert my velocity, I have to sit and reconvert again. Think smart, convert the time over here. Right. So, we have come to the end of the CDS 2 2021 PYQ discussions. Thanks for watching the video. Subscribe for the channel to know more about PYQs from all the other subjects as well as from physics. Thank you.